Identify the nature of the titration. The reaction involves a strong acid and a strong base. In such titrations, the net ionic reaction is H to the power plus plus OH to the power negative gives H2O, which goes to completion. Analyze the titration curve. As seen in standard titration curves, there is a nearly vertical region at the equivalence point. This verticality indicates that the pH changes extremely rapidly with the addition of a very small volume of titrant. Apply the logarithmic scale of pH. Because pH is defined as log H to the power plus, a small change in the concentration of hydrogen ions near the equivalence point results in a mathematically large change in pH. Connect pH change to the indicator. Phenolphthalein is an organic dye that changes color within a specific pH range, typically 8.2 to 10.0. Near the endpoint, the concentration of H to the power plus or OH to the power negative is so low that one single drop of base provides enough OH to the power negative ions to cause the pH to jump across the entire color change interval of the indicator. Explain the reversibility. Because the pH is sitting on a steep cliff on the titration curve, adding one drop of acid restores a high enough H to the power plus to immediately drop the pH back below the indicator's range, switching the color back. Therefore, the abruptness is caused by the solution's pH behavior, not the indicator itself. The correct answer is option A. A large change in pH occurs near the endpoint of the titration.